They don't go into each other? Square root is on the bottom?
Bingo.
Oh.
If you recall, when we're talking about fractions, one way I look at it is the number on the top is the number of pieces you have, and the bottom number is the number of groups you're breaking it into, right? What is the square root of 5? It's some decimal that never ends and never repeats. So how do you break something into that many groups? Does that make any sense?
No.
So how can you get the radical out of the bottom? What's that? By what? Just like any other fraction, we could take 3/5 and make it look like something else by multiplying it by something over itself, right? We did that all the time to get common denominators. We can do the same idea here. What would get rid of the square root of 5? Another square root of 5. The square root of 5 over the square root of 5 is just like 2 over 2. It's equal to 1. So we're not changing the value. We're just changing the color of the frosting. So if we multiply across the top, I got 3 square root of 5. Now keep in mind the square root of 5 times the square root of 5. There's several ways you can look at it. You can put it together and call it the square root of 25, which is 5. You can think of it as square root of 5 times square root of 5 is the square root of 5 squared, isn't it? And squares and square roots undo each other. Or you can think about it as the square root of 5 times the square root of 5 is the square root of 5 with the 2 on the inside. And again, squares and square roots undo each other. Or you can be like Craig and go, oh, the square root of 5 times the square root of 5 is whatever's inside. Any square root times itself is whatever the inside number is. Boom.
Always?
Always. Because the square root times the square root is it squared, isn't it? Basically what this is the shortcut for looking at it any of those 3 ways. Square root of x times square root of x is x. What now?
That would be the answer to that.
Does that fraction reduce any further? Do we know what the square root of 5 is? It goes on forever. So if we multiply by that by 3, it still goes on forever. How do you cancel something that goes on forever with something that stops, like 5? So yes, you're correct. This is all the farther that one goes.
Also, square root of 5 and 5, they're not the same, so you can't
Right.
try to cancel them.
Good point. Number one mistake is people say, oh, square root of these will cancel, right? If you add x over x squared, does both of them cancel completely when you could say, oh, this cancels with that, but you still have something left over, don't you? Kind of the same idea. These don't cancel because this is not the same as that. Now be careful. What if instead it had been 6 over the square root of 10? And we do the same thing. And have a radical in the bottom. So now that lets anybody keeping a list of the things you can't have in the bottom? Not allowed in the bottom of a fraction. What were they? Anybody? 0. Good. What else? Negative. What else? One we probably didn't talk about much, but you can't have decimals in the bottom of a fraction, because how do you divide something into 0.4 parts? And then 4, any kind of radical. So how do you get rid of that square root of 10?
Multiply by square root of 10.
Square root of 10 over the square root of 10. So that's going to give us 6 square root of 10 on the top. What's that going to give us on the bottom?
Square root of 10.
Square root of 10 times square root of 10 is?
Oh, 10.
10. How is this one different? Or is it?
About 6 and 10 reduce.
Bingo. Bingo. Can you reduce the 6/10 part? What I often do is think of it like this. A fraction and the square root separately. Remember, we talked about radicals, you can treat them like variables. If you add 6x over 10, you can think of it as 6 over 10x, because then you can reduce the fraction, right? 3 over 5. Same thing here. 2 goes into both of these. 3 square root of 10 over 5. And again, the 5 does not cancel with the 10. You can't go, 5 goes into 10, so you got 3 square root of 2. Uh-oh. Any others from that left side? Oh, 48 is going at that. Shall we up the ante and go over to the right side?
Let's do that.
Now, wait, before we do, I'm looking at 39 through 46. That's 46 so much, or 45. I guess I'm looking at 39, 40, 41, 42. If you look at something like 39, what could you do with this? Could you do what we just did with it? Option 1. Now we can do the square root of 48 over the square root of 48, square root of 48, which gives us then 6 square root of 48 over 48 times square root of 8 is, it's got a 48 is 48. Are we done? What can you do, Jeremy? What's that?
You put 2 into 48 and 46.
Which 48? The blue 48 or the
bottom.
okay. In other words, you can the fraction part, right? Well, in fact, couldn't we do the whole 6?
Oh,
Yeah, 6 goes into 48 8 times. So are we done?
Would have put the 1.
Do you need it? You can. But you know, math people being lazy. 1 divide 1 times. Are we done here? What's that? I disagree. If you put that into my math lab, they're going to tell you you're wrong. The message is it's not simplified. Can you break down the square root of 48? Is there a square that goes into the square root of 48? One of my favorites. Talk about it in class often. 16 and 3. Where's my 8? Running out of room. Square root of 16 is 4. Are we done yet? Well, 4 and 8 cancel, don't they? End up with square root of 3 on the top and 2 on the bottom. Where'd I lose you?
Okay, after we multiply it by square root of 48 on the top and the bottom.
Right?
After that, that's where I got lost.
Okay, so then we divide, we've got 6 square root of 48 over 48. We can reduce the 6 over 48 part.
Oh, right.
That leaves me square root of 48 over 8. But the square root of 48 breaks down. The biggest square that goes into 48 is 16. So that's where the 16 and the 3 come from. Can you do the square root of 16? Yeah, it's 4. So that leaves me now with 4 times the square root of 3 over 8. And 4 over 8 reduces, doesn't it? A bit confusing. Is there another option? Option 2. Break down what's in the radical first. 6 over the square root of 48. We just said that that is, what colors did I use? That's the square root of 16 times the square root of 3. Agreed?
Mm-hmm.
Which would make this then 6. And now where do you want to go? Do we have to multiply the whole bottom by itself? The only thing I have to get rid of on the bottom is the radical. So instead of multiplying by the whole square root of 48, I really only have to multiply by the square root of 3.
So this is a shorter way.
It's still going to have a lot of steps to it. Either way. But now on the bottom, I got 4. Square root of 3 times the square root of 3 is 3. That's going to leave me 6 times the square root of 3 over 12.
So how come with the last one that we did, when the answer was 3 square root 10 over 5, square root of 10 didn't break down to something?
Is there any squares that go into 10? 10's not a square. Breaks into 2 and 5. They're neither one of them are squares. So would breaking it down help? No. We break it down because there was a square here. Square root of 16 is 4. So that part will break down. If you like it better that way, it doesn't really matter which way you go around about it, but you do have a couple of options. But you're going to have to keep track of all the details. Some of them they give you pretty straightforward, like the one earlier with 5. 5 doesn't break down. 48, that breaks down all kinds of different ways. And similarly, if you have the alphabet involved, like 41 or 42, which one do you prefer? Really, which one do you want? 41 or 42?
42.
42.